Hey everyone, this is Apple from the AppleKnows channel, and today, I'm about to blow your mind with some of the most unbelievable, real facts about the universe. You might think you've heard it all about space, black holes, stars, planets, but trust me, what I'm about to tell you will make you question everything you thought you knew about reality itself. Let's start with something that sounds like science fiction but isn't. There's a planet out there, 55 Cancri, that's twice the size of Earth, and it's made mostly of diamond. Yeah, you heard that right. A real planet, shining in the darkness of space, made of solid diamond. Imagine a world where mountains of diamond rise under a black, burning sky, where a single boulder could make you wealthier than the entire Earth. And yet, that world burns at over 2,400 degrees Celsius, so even if we could reach it, we'd never make it back to tell the story. Now, you probably know about black holes, those monstrous pits of gravity that devour everything, even light. But here's what most people don't realize: black holes aren't really holes. They're points of infinite density, singularities, where all known laws of physics collapse. Imagine something so dense that if you compressed the entire Earth to the size of a marble, it still wouldn't be dense enough to become a black hole. And get this, time itself slows down near them. If you were watching someone fall into a black hole, you'd see them freeze, suspended forever at the edge, their light stretched and red shifted into oblivion. From their perspective, though, they'd plunge in without realizing that for the rest of the universe, their fall would take eternity. But not all cosmic monsters are black holes. Somewhere out there are neutron stars, the remnants of exploded supernovas. Just 1 teaspoon of a neutron star would weigh about 1 billion tons. Imagine dropping that on your kitchen floor. These stars spin at insane speeds, hundreds of times per second, creating magnetic fields so strong they could tear apart atoms. One type, called magnetars, have magnetic fields 1 trillion times stronger than Earth's. If you were within 1,000 kilometers of one, it could literally erase your entire molecular structure. And speaking of insanity, let's talk about the Boötes void. It's a region of space so massive, so empty, that it defies comprehension. It's a cosmic desert 330 million light-years wide, containing almost nothing. No galaxies, no stars, just endless darkness. Some astronomers call it the Great Nothing. If the Milky Way were placed inside it, we'd have no idea other galaxies even existed. It's like staring into the face of cosmic isolation. But the universe isn't all empty space and death. There's also beauty in chaos. Take the pillars of creation, those towering clouds of gas and dust captured by the Hubble telescope. They're light-years tall, birthing new stars even as they're slowly being destroyed by nearby supernovas. What you're looking at when you see that photo is ancient light. Those structures might not even exist anymore. What you see is a ghost image from thousands of years ago. And here's something that really bends the mind: there are more stars in the universe than grains of sand on every beach on Earth. Yet, somehow, we're sitting on one small blue planet, talking about it. Just think about that scale for a second. Every star could have its own system of planets, its own worlds, maybe even life forms looking up at their own sky, wondering the same thing we do: are we alone? But it gets stranger. Scientists recently discovered a planet called WASP 76b, where it rains iron. On one side of the planet, temperatures are so high that metals evaporate into the atmosphere, and when winds blow to the cooler side, that vapor condenses and falls as molten iron rain. Imagine standing under a sky that bleeds metal. And if that doesn't mess with your perception, here's another one: space smells. Astronauts who returned from spacewalks said the airlock smells like seared steak, hot metal, and welding fumes. It's caused by high-energy vibrations from atomic oxygen interacting with spacecraft materials. The scent of cosmic radiation, they call it the smell of the stars themselves. Oh, and here's one that will make you rethink everything you've seen in the night sky. When you look at the stars, you're not seeing them as they are now. You're looking into the past, sometimes millions or even billions of years back. Some of those stars might not even exist anymore. Every time you gaze at the night sky, you're literally witnessing ancient history, like traveling across cosmic time to reach your eyes. And yet, despite everything we know, and all we've discovered, scientists estimate we still understand less than 5% of the universe. The rest is dark matter and dark energy, invisible and untouchable. We don't know what it is, only that it's there, shaping everything: galaxies, stars, even our own existence. Let's talk about rogue planets, worlds that drift through the darkness of space without a star to orbit. There could be trillions of them, silently floating between galaxies, eternally lost. No sunrise, no seasons, just cold, black emptiness. Some scientists think these planets might even have underground oceans heated by their own cores, meaning that, somewhere out there in the void, life could be hiding, thriving in complete darkness. Imagine that, a whole alien ecosystem, living without ever seeing a single ray of light. And then there's a star system called HD 189733b. When astronomers first observed it, they discovered something that sounds like a nightmare: the planet rains glass sideways. The wind speeds there reach over 8,000 kilometers per hour, fast enough to rip apart anything in seconds. The skies are a deep cobalt blue, but not because of water, because of silicate particles reflecting light. It's a storm world where it literally rains shards of glass, and every gust could shred steel like paper. Now, let's move closer to home. The sun, that glowing, warm presence we take for granted every day, is a monster. Every second, it releases more energy than humanity has used in its entire history. And inside it, hydrogen atoms smash together to form helium, releasing blinding heat and light through nuclear fusion. What's more, the light that leaves the sun's surface took thousands of years just to travel from its core to the surface. By the time it reaches your face, you're feeling ancient energy that began its journey long before civilization even existed. But here's something even more haunting. The sun will die. In about 5 billion years, it'll run out of fuel, expand into a red giant, and swallow Mercury and Venus. Earth will either be incinerated or thrown into space. For a short moment, the sky will blaze blood red before everything we know melts away. Then the sun will shrink into a white dwarf, a dense, ghostly ember no bigger than Earth, glowing faintly in the dark. A cosmic tombstone marking what used to be our solar system. And yet, in the distant corners of the galaxy, stars die even more violently. When a massive star collapses, it creates a supernova, an explosion so powerful that for a few weeks it can outshine an entire galaxy. One of these could erase life on any nearby planets in an instant. The shockwave travels at thousands of kilometers per second, spreading heavy elements like iron, gold, and oxygen across space. The truth is, every atom in your body, every bit of calcium in your bones, every iron atom in your blood was forged in the heart of a dying star. You are literally made of stardust. And if that didn't twist your brain enough, think about this: the largest known structure in the universe is called the Hercules, a corona borealis Great Wall, a cluster of galaxies so huge it spans 10 billion light-years. For context, light from one side would take longer to reach the other side than the universe has even existed since the Big Bang. This thing shouldn't even be possible according to our models of cosmic formation. It's so vast that scientists still argue about whether it's one structure or just a coincidence of alignment, but it's real, and it's out there, mocking our understanding of space. And speaking of impossible things, there's something called quasistars. They existed only in the early universe, stars so massive that they could hold a black hole at their core without collapsing. Imagine a black hole devouring its own star from the inside out, feeding endlessly, wrapped in a glowing cocoon of light 1,000 times brighter than our sun. They no longer exist, but their remnants might, black holes larger than anything we can imagine, still haunting the deep cosmos. Here's something that sounds like fantasy but isn't. Astronomers have detected a mysterious radio signal that repeats every 16 days, coming from deep space. It's not random, it's rhythmic, precise, like a heartbeat in the dark. Scientists have theories, maybe a magnetar, maybe binary stars, but no one really knows. It's like the universe whispering in a code we haven't yet learned to decipher. And then there's Oumuamua, the first known object from another star system to pass through our solar system. It wasn't a comet, not an asteroid, something completely different. It accelerated as it left our system, as if pushed by some invisible force. Some scientists even speculated it might be an alien probe. We don't know what it was. All we know is that it came from somewhere unimaginably far away, and it left without a trace. So, when you look up tonight and see that faint glimmer of light, remember this: you're not just staring into space. You're looking into time, into stories billions of years old, into the raw truth of existence itself. Let's start with something that feels like a glitch in the cosmic code: the concept of gravitational time dilation. Einstein predicted it, and it's been proven. The closer you are to a massive object, the slower time moves for you. This isn't theory, it's real physics. Astronauts aboard the International Space Station actually age slightly slower than people on Earth. Just a fraction of a second, sure, but measurable. And around a black hole? A few minutes near its edge could equal years or centuries in the outside universe. That means, hypothetically, someone could orbit a black hole for a few hours and return to find that millennia have passed on Earth. The universe doesn't just stretch space, it bends time itself. And speaking of time, let's talk about the oldest thing we've ever seen. It's called the cosmic microwave background, the afterglow of the Big Bang itself. This faint radiation fills all of space, a whisper from the birth of everything. When we study it, we're literally seeing the universe as it was 13.8 billion years ago, just a few 100,000 years after time began. The most ancient light ever recorded, and it's still echoing around us right now. You're bathed in it at this very moment, whether you're inside your home or staring up at the night sky. But not everything in the cosmos follows the rules we expect. Take Sagittarius A*, the supermassive black hole at the center of our galaxy. It's about 4 million times the mass of the Sun, yet it's smaller than the orbit of Mercury. Every star you see in the Milky Way is slowly circling around it, like a vast cosmic carousel. And recently, scientists captured the first ever image of it, a glowing, swirling ring of light around a shadow that's not really there. A literal photograph of the point where space and time collapse. And here's something few people realize: black holes evaporate. According to Stephen Hawking's discovery, they emit radiation, tiny particles escaping their pull, and over unimaginable stretches of time, they shrink and eventually vanish. Theoretically, at the end of everything, when the universe goes dark and cold, the last flickers of Hawking radiation from dying black holes will be the final light in existence. The ultimate end, a silent fade into absolute nothingness. But before that happens, the universe might pull one more trick: expansion. Right now, the universe is not just expanding, it's accelerating. Galaxies are rushing away from each other faster and faster. Someday, billions of years from now, distant galaxies will disappear beyond the cosmic horizon. If any beings exist then, they'll look at the sky and see nothing but darkness. They won't even know there was ever a universe beyond their own galaxy. We are living in the brief moment of cosmic visibility, the era when the universe still lets us see its secrets. And then there's the Great Attractor. Sounds like a movie title, right? But it's real, a gravitational anomaly pulling our entire galaxy, along with thousands of others, toward it at over 600 kilometers per second. We can't even see what it is because it's hidden behind the Milky Way's dust. For decades, scientists have tried to figure out what's pulling us, some massive cluster, maybe dark matter, but the truth is, we still don't know. The entire Milky Way is being dragged towards something invisible. Now, let's zoom in on one of the strangest cosmic discoveries ever: dark flow. Scientists observed that clusters of galaxies seem to be drifting in one direction, as if something outside the known universe is pulling them. That's right, something beyond the observable universe, something we can't see, might be influencing the motion of entire galaxy clusters. It's as if our universe isn't alone, but part of something even larger, a multiverse, perhaps, or a structure beyond comprehension. And if that doesn't make your head spin, listen to this: there's a region of the sky known as the cold spot. It's an area of the cosmic microwave background that's much colder than anywhere else, and no one knows why. Some theories say it's a void, a huge empty patch of space. Others suggest it might be evidence of a collision with another universe. Just imagine, our universe might have brushed against another one. Even light, that thing we take for granted, isn't constant in every situation. It bends around gravity, curves through spacetime, and can even be trapped by strong gravitational fields. We've detected galaxies so perfectly aligned that the light from one bends around another, creating what's called an Einstein ring, a glowing circle of light formed by the curvature of space itself. You're not looking at science fiction, you're seeing the literal warping of the universe. And what about sound in space? You've heard it said there's no sound in space, but that's not entirely true. NASA has recorded sound waves rippling through clusters of hot gas in deep space, the lowest note ever detected, 57 octaves below middle C. It's a sound so deep that it takes 10 million years to complete one vibration.
The universe isn't silent, it's humming, forever, in a cosmic tone we can't hear but can measure.
The universe, as it turns out, isn't just vast, it's alive with motion, with rhythm, with energy that never ends.
And every discovery we make just opens more questions than answers. Let's start with something small, really small, the quantum scale of our universe.
The rules of space and time break down completely here. In the quantum world, particles can exist in multiple places at once, vanish and reappear, even communicate instantly across vast distances.
It's called quantum entanglement, and Einstein himself called it spooky action at a distance.
When two particles are entangled, changing one instantly affects the other, no matter how far apart they are, even light years away.
Think about that.
Somewhere out there in the galaxy, an atom could be entangled with one right here on Earth, both reacting as one. That means, at the most fundamental level, the universe might be connected in ways we can't yet understand. Now imagine zooming back out from the smallest scale to the largest.
There's a supercluster called Laniakea, and it's where we live.
It's an enormous structure of over 100,000 galaxies, including our Milky Way. Together, they move like a single cosmic organism through the universe, drawn by the mysterious pull of gravity.
Our galaxy is just a single grain in this colossal river of galaxies, flowing through an invisible current of spacetime.
When you step outside at night and look up, you're looking out from inside that flow. And here's something that will absolutely melt your sense of scale: the largest known star is called Uy. If you replaced our Sun with it, its surface would reach past Jupiter. It's so big that light takes hours just to cross it. And yet, compared to the size of the universe, even this monstrous star is microscopic, a spark floating in a black ocean billions of light years deep.
But not everything huge is bright. Some stars die and become what we call black dwarfs, theoretical remnants of white dwarfs that have cooled completely. None exist yet, because the universe isn't old enough.
They'll appear only after trillions of years, when all stars have faded and the cosmos is dark and cold.
The first black dwarf won't even exist until long after every galaxy has vanished from sight.
That's how young our universe still is, it hasn't even started its final act.
And speaking of endings, let's talk about one of the strangest theories in physics, the heat death of the universe.
Over unimaginable stretches of time, all stars will burn out, all black holes will evaporate, and energy will spread so evenly that no movement, no thought, no life can exist.
The universe will reach maximum entropy, absolute stillness. No light, no warmth, no sound. Just infinite, silent darkness. That's one possible ending. Another? The Big Crunch, where gravity reverses the expansion, pulling everything back into a single point.
Or maybe even the Big Bounce, where everything collapses and explodes again in an endless cycle of creation and destruction.
And then there's one more possibility, the Big Rip.
The universe keeps expanding, faster and faster, until galaxies, stars, planets, and even atoms themselves are torn apart by the stretching of spacetime.
Reality itself unravels.
It's a scenario so extreme that even light wouldn't escape the chaos. But let's move to something that sounds impossible yet has been observed.
There are planets that orbit two suns, just like in science fiction. Kepler 16b is one of them, a real-life Tatooine.
Imagine standing on its surface, watching two suns rise and set, casting twin shadows across red deserts. And beyond that, there are planets so close to their stars that a single year lasts just a few hours. Others are so far away that one orbit takes thousands of Earth years. In the vast lottery of the cosmos, almost anything you can imagine already exists somewhere. Now, consider this: every time a massive star explodes, it sends shockwaves that trigger the birth of new stars. In other words, every death in the universe leads to new life. Our sun was born from the remains of dead stars, and one day, its own death will give birth to new worlds. The universe recycles itself endlessly, a chain of creation and destruction written in fire and light. And what about the possibility of other intelligent life? The numbers are staggering. There are about 200 billion stars in our galaxy alone, and possibly 2 trillion galaxies in the observable universe. Even if just 1 in a billion planets could support life, that still means millions of potential civilizations could exist.
But here's the haunting part, the Fermi paradox. If the universe is full of life, where is everyone?
Maybe civilizations rise and fall too quickly to meet.
Maybe they're hiding.
Or maybe, just maybe, we're early, the first spark of consciousness in a still young cosmos. And if you want something truly eerie, scientists have detected signals from pulsars, spinning neutron stars that emit perfectly timed radio pulses.
Some early astronomers thought they might be alien beacons. They were nicknamed LGM, Little Green Men.
Turns out they're natural, but still, their precision is frightening. Some pulse more regularly than the best atomic clocks on Earth. The universe has its own heartbeat, constant, eternal, and older than time itself. And then there's the concept of cosmic censorship, the idea that the universe hides its most violent events, like singularities, behind horizons so we can never see the truth. Maybe nature itself is protecting us from understanding too much. Maybe the real structure of reality, what lies beyond space and time, is something we're not meant to comprehend yet. One of the most chilling realities we've discovered, cosmic radiation. Right now, at this very moment, high-energy particles from deep space are passing through your body. Through your skin, your bones, even your DNA.
Every second.
You're being bombarded by tiny fragments of supernovas, by ancient cosmic rays born from events that happened millions or billions of years ago.
They pass through you like you're not even there.
Most are harmless, but some may have helped trigger mutations in our ancestors that shaped human evolution. In a way, you're literally connected to the explosions of dead stars, not just by atoms, but by the invisible rain of energy they still send out. And then there's something stranger, the idea of cosmic strings. Hypothetical cracks in the fabric of spacetime, thinner than an atom but heavier than a galaxy.
If they exist, they're leftover scars from the Big Bang itself.
Passing near one could bend light, warp time, or even tear reality. We've never detected one, but the math says they could be out there, slicing across the universe like invisible wires under infinite tension. Imagine a thread so powerful it could cut a planet in half just by existing.
Let's move from the theoretical to the very real.
One of the weirdest objects ever discovered is the double pulsar PSR J0737-3039.
Two neutron stars locked in a deadly dance, spinning around each other dozens of times a second.
Each one emits beams of radiation so precise we can watch them eclipse each other with clockwork perfection.
This system lets scientists test Einstein's theories in ways we can't do anywhere else.
It's like a natural laboratory for the extreme, a cosmic particle accelerator bigger than any machine we could ever build.
And then there's the terrifying concept of gamma-ray bursts.
These are the most powerful explosions known, capable of releasing more energy in a few seconds than the sun will emit in its entire lifetime. If one went off close enough to Earth, it could strip our atmosphere and sterilize the planet in seconds.
Thankfully, they're rare and mostly happen far away, but they're out there, ripping through galaxies like cosmic flashbulbs. Here's a fact that will completely warp your sense of solid ground. Space itself isn't empty.
It's filled with quantum fields, virtual particles popping in and out of existence constantly.
Even a perfect vacuum isn't truly empty, it's alive with fluctuations.
In fact, those quantum jitters are what gave birth to the large-scale structure of the universe. The galaxies, stars, and planets you see today started as microscopic quantum fluctuations in the early cosmos. You're living inside a magnified ripple of nothing.
And then there's a question that keeps cosmologists awake at night: why does anything exist at all? According to physics, the Big Bang should have produced equal amounts of matter and antimatter.
But if that had happened, they would have annihilated each other instantly, leaving nothing but light.
Yet here we are. Somehow, for some unknown reason, there was just slightly more matter than antimatter, a 1 in a billion imbalance that allowed every atom in the universe to form. That tiny asymmetry is the only reason you exist. Let's talk about that axis of evil. No, not politics, this is a real term in cosmology.
When scientists mapped the cosmic microwave background, they found a strange alignment of temperature fluctuations. Patterns across the entire sky, lined up in a way they shouldn't be.
Some think it's a statistical fluke. Others think it's evidence of something bigger, maybe the shape of the universe itself, or an imprint from before the Big Bang.
It's called the axis of evil because it violates our expectations so deeply it almost feels like a cosmic prank. And here's one more thing to melt your mind: the holographic principle.
Some physicists think our entire three-dimensional universe might actually be a projection of information encoded on a distant two-dimensional surface. In other words, reality might be a hologram. The math behind black holes supports this.
Everything you see, touch, and feel your entire life could be a shadow of a deeper, hidden reality.
It's not science fiction.
It's one of the leading theories in modern physics.
And finally, consider this: the observable universe is 93 billion light-years across, but that's just what we can see.
Beyond that, space goes on, maybe forever.
Infinite stars, infinite galaxies, infinite worlds.
Somewhere out there, in that infinite expanse, there could be another Earth, another you, living a life just slightly different.
Maybe in that universe you're not watching this video. Maybe you're the one making it. This is Apple from AppleKnows, and after all of that, we've come full circle. The universe is more than just stars, planets, and black holes.
It's a story of impossibility becoming reality, of beauty and terror coexisting on a scale beyond comprehension. Diamond planets, raining iron, invisible matter, cosmic webs, the birth and death of time itself, all of it real, all of it happening right now. And yet, even after centuries of studying the sky, we've barely scratched the surface.
95% of the cosmos is still a mystery. We don't know why the universe exists. We don't know what came before it, or what comes after. We don't even know what after means.
But here's the truth: the atoms in your body were forged in the cores of ancient stars, scattered by explosions, gathered by gravity, and brought together on a small blue planet orbiting an average star.
You're not separate from the universe. You are the universe, awake and aware, looking back at itself and asking questions.
So the next time you look up at the night sky, remember this: those tiny points of light aren't just stars.
They're messages from the past, signposts of infinity, reminders that you are part of something far bigger and stranger than you can possibly imagine. This is Apple from AppleKnows, signing off.
Stay curious, because reality is always stranger than fiction.